In the mid-18th century, in a damp island off the northwest coast of Europe, a cluster of inventions began to turn water and coal into wealth, and to reorder daily life in ways no one fully anticipated. Britain had some advantages that mattered: accessible coal seams, navigable rivers and coasts, a dense network of turnpike roads, growing overseas markets in its empire, and a legal financial system that supported investment and patenting. But the transformation was not inevitable. It was built piece by piece in workshops, mines, mills, and laboratories. Cloth was at the heart of the first industrial takeoff. For centuries, English textile production had been a cottage industry, spinners and weavers working in their homes, often supplementing farm income, paid by merchant putters out, who supplied raw wool or cotton and collected finished yarn or cloth. By the 18th century, cotton from the Caribbean, the American South, and India was pouring into British ports, in part because it could be machine processed more easily than wool, and because slavery and empire made it, brutally, cheap. Demand for lightweight cotton textiles surged at home and abroad. But the traditional system had bottlenecks. Hand spinners could not keep up with weavers. Cloth was in short supply and expensive. Then, in a rapid sequence, new machines altered the balance. In 1733, John Kay, a Lancashire inventor, patented the flying shuttle. A simple but powerful improvement. It let a single weaver operate a loom that previously required two, and allowed wider cloth to be woven faster. Weaving sped up, which now made spinning the main bottleneck. Around 1764, James Hargreaves, a weaver and carpenter, invented the spinning jenny, a hand-powered frame allowing one worker to spin multiple spindles of thread at once. The jenny multiplied yarn output, especially for the coarser weft threads. It was still suited to home or small shop use, but it dramatically raised productivity. In 1769, Richard Arkwright, a former barber and entrepreneur, patented the water frame. It used water power to drive rollers that spun stronger cotton yarn suitable for warped threads. The scale and power requirements meant it worked best in large, centralized buildings, the first true factories. Workers operated rows of machines under a single roof, on a tight schedule set by the flow of the water wheel. In 1779, Samuel Crompton combined features of the jenny and the water frame to create the spinning mule, capable of producing fine, strong yarn in large quantities. It quickly became the backbone of spinning in industrial cotton districts. Together, these inventions made it possible to mass-produce cotton thread and cloth at unprecedented speed and scale. By the early 1800s, mill towns like Manchester, Bolton, and Oldham became synonymous with cotton, their skylines pierced by chimneys and mill towers. But machines needed more than water. To build machines, you need metal. Early iron production depended heavily on charcoal, limiting output because woodlands were finite. A breakthrough came in 1709, when Abraham Darby I, working in Coalbrookdale in Shropshire, successfully used coke, a coal derivative baked to remove impurities, as fuel in a blast furnace to smelt iron. Coke-fired iron production was initially specialized, but over the 18th century it spread. Using coal instead of charcoal meant Britain could tap its large coal reserves without stripping for a spare. More iron meant more tools, more machines, more rails, more engines. In 1784, Henry Cort patented the puddling process and rolling mills, which allowed pig iron to be refined into wrought iron in larger quantities. Iron masters stirred molten iron in reverberatory furnaces, exposing it to oxidizing conditions that removed carbon and impurities. Rolling mills shaped the hot iron into bars and plates. Iron production soared, feeding machine building for textile mills and other factories. Civil engineering, bridges, like the famous 1779 Iron Bridge at Coalbrookdale. Weapons and ships. Coal, already key for heating and brewing, became the fuel of industry. But extracting coal and pumping water from deeper mines required energy. That need drove the next leap. Britain's mines often flooded. In the early 18th century, Thomas Newcomen developed an atmospheric steam engine, circa 1712, that used steam to condense and create a vacuum, pulling down a piston and operating a pump. Newcomen engines were clumsy and consumed vast quantities of coal, but in coal-rich regions they were good enough to drain mines and keep production going. In the 1760s, a Scottish instrument maker named James Watt examined a model Newcomen engine. He realized that repeatedly heating and cooling the main cylinder wasted enormous energy. His key innovation, patented in 1769, was the separate condenser, a chamber where steam could be condensed without cooling the cylinder itself. This dramatically improved efficiency. Teaming up with the Birmingham entrepreneur Matthew Boulton, formal partnership in 1775. Watt refined and commercialized steam engines. Over the next decade, he added sun and planet gears and later cranks, circa 1781, to convert the engine's reciprocating motion into rotary motion suitable for driving machinery. Developed double-acting engines, circa 1782, where steam pushed the piston in both directions, increasing power and smoothness. The result was transformative. Steam engines no longer just pumped water. They became general-purpose power sources that could drive mill machinery, hammers, and other devices. Crucially, they could be located away from rivers, as long as coal and water could be supplied. Factory owners were no longer chained to waterfalls. Power could be sited near coal fields or in growing towns. By the late 18th century, the combination of cheap coal, improved iron, and efficient steam engines had created a new triad of power. But its effects were not confined to factories. As water frames, mules, and steam engines spread, the organization of work changed. The older putting-out system had offered some flexibility. Spinners and weavers worked at home, setting their own hours, within limits imposed by necessity and merchant demands. Factory production brought workers into centralized spaces under direct supervision and the relentless pacing of mechanized processes. In mills and factories, time discipline became strict. Bells and factory whistles marked start and end times. Clocks, not sunrise and sunset, regulated the day. Wages were increasingly paid in coins or tokens for time worked, rather than in kind or by piece alone. Rules governed conduct. Fines for lateness, for talking, for damaging equipment. Children could be beaten for falling asleep at machines. The new industrial towns, like Manchester, Birmingham, and expanding parts of Glasgow and Leeds, grew quickly. Rural families migrated in search of wage labor, filling cramped back-to-back houses and hastily built tenements. Sanitation lagged. Open sewers, contaminated water supplies, and smoke-filled air bred disease. For many workers, industrialization meant more regular cash income, but also long hours, often 12 to 14-hour days, 6 days a week. Monotonous, repetitive tasks. Dangerous conditions near unguarded belts, gears, and shafts. Children as young as 6 or 7 were employed in textile mills, as piecers and scavengers, and coal mines, as trappers, hauling or opening ventilation doors, or dragging coal in low tunnels. Women worked in mills and in some mines, often for lower wages than men. Britain was becoming a manufacturing, urban society, even as much of Europe still remained predominantly agrarian. Industrial growth depended on moving stuff: coal to factories, cotton to mills, iron to foundries, and finished goods to markets and ports. At first, canals provided the solution. In the mid-18th century, engineers like James Brindley made waterways such as the Bridgewater Canal, opened 1761, linking coal mines at Worsley to Manchester. Canals dramatically reduced transport costs and encouraged clustered industrial development along their routes. But soon a new technology began to supplant canals for certain purposes: the railway. Early railways, wooden or iron rails with horse-drawn wagons, already existed within mines and quarries. What changed in the early 19th century was the application of steam locomotives. George Stephenson, a self-taught engineer, built early locomotives for colliery lines in northern England. In 1825, the Stockton and Darlington Railway opened in northeastern England. Designed to haul coal from mines to port, it is often cited as the first public railway to use steam locomotives regularly for freight and, on some trains, passengers. Continued in Part 2.